Hello, welcome to Flipped. Today we are on electrolysis, which is the conduction of electricity by ionic compound, which are called electrolytes, which can be either molten or dissolved in water. So there are two forms of them, leading to the decomposition of electrolytes themselves. So this is a setup of a basic electrolysis experiment. What we have here on top is the battery, okay? This is a cathode, and this is an anode. Together they make up the broader term of electrode, okay, which we'll talk about later. And this one, this pool of water, okay, which is not water, it's actually ions being dissolved or molten. They are called electrolytes. We'll talk about them in detail as well. Let's start off with battery and electrodes. So what we have here are batteries, okay, these are two batteries actually. Okay, the shorter one, the shorter end, okay, as you recall, the shorter end, this one, okay, is a negative end, whereas the positive one, the longer side is the positive terminal. Okay, shorter one is negative, longer one is positive, and there are two batteries here. Okay, next one is electrodes, which acts as the medium for electrons to enter or to leave electrolyte. And they can be reactive, okay, the electrodes themselves can be reactive in the case of copper, or they can be inert in the case of carbon or platinum. Okay, so electrodes, okay, are this one, the cathodes and the anodes. They allow electrons to go into electrolyte and to come out from electrolyte. Okay, basically that's their job. It's like a gateway between the wires and the electrolyte. So there are two kinds of electrodes. First one we call it anode. It's called a positive electrode because it's connected to the positive end of the battery, as we talked about this just now. Okay, this longer end is the positive one. So you can see that this anode, okay, I've drawn a bigger one here for you, is that this anode is connected to the positive end. That's why it's called a positive electrode. Okay, and that's why, because it being positive, okay, it will attract all the negative ions to it. Makes sense, right? Because opposite charge attracts. Okay, so being positive, all the negative charge will just aggregate around it. Okay, it will just cluster around it. Okay, and this is very important when we talk about the setup later. On the other hand, we have this thing called cathode, which is the opposite of anode. Now it's the negative electrode because it's connected to the negative end of the battery. So the negative end is the short one, right? And you can see that, okay, cathode is connected to the shorter end, shorter terminal of the battery. And it being negative in nature, it attracts, okay, as you have guessed it, all the positive charges around it. Okay, all the positive charges will want to aggregate around it because opposite charge attracts. Okay, so as a recap, the anode is surrounded by all the negative ions, whereas the cathode is surrounded by all the positive ions because of their charges individually. Okay, hopefully this diagram is helpful for you. Okay, so now we have talked about cathode, anode, and battery. Let's talk about electrolyte. So these are electrolyte. This is a definition of electrolyte. It's basically liquid that contains mobile ions. Okay, they can be either in molten state, okay, or aqueous state. Let's talk about molten state first. Basically, the ionic compounds melted at high temperature to get molten state. So what I result in, okay, are just this random allocation, okay, because it's liquid state now, of ions. Okay, so it's just randomly flowing around. Okay, these are molten ions. So there are positive and negative charges. Where there's one way, okay, of existing as an electrolyte. Second way is to exist as an aqueous state, which is actually exactly the same thing, except, okay, let me just try and replicate what I've drawn here. So this is exactly the same thing as molten state, but now they are surrounded by, okay, let me just use blue to indicate water molecules. Okay, sorry about that, yep. So all these blue ones are water molecules surrounding the positive and negative ions. So essentially, these two states are the same, okay? They both have free-flowing ions, okay? But the only difference is that aqueous state has water molecules surrounding them in their midst, basically. Okay, that's the main difference between them. But other than that, they do the same thing. Basically, they can both conduct charges. Okay, they can move charges from one end to the other end, okay, for both molten and aqueous state. So how to get aqueous state is basically you dissolve ionic compound in water. Okay, next one is very important. We know that solid state is unable to conduct electricity because ions are in fixed position. Okay, so let me just take all these ions back and put them into nice order. So they look like this now. Okay, one positive charge is neutralized by one negative charge. Okay, in the case of, for example, NaCl. Okay, this is a very, very simplified drawing of it. Okay, let me just finish this drawing. Okay, you can see that each positive charge is neutralized by a negative charge. Okay, and you can see that they are in very fixed orderly shape. And so when we melt or dissolve this solid ionic compound, okay, either we melt to get molten state or or dissolve in water to get aqueous state, this structure is destroyed. Okay, this is called a lattice structure. It's being destroyed. Okay, basically all the bonds here are being in some sense broken. Okay, so that all these ions are now very free to move about. Okay, they have their own free will. Okay, they can move freely and they can conduct electricity. And this is very important because it's evidence to show that ions in solids, okay, are held in lattice structure, but free to move when in molten or aqueous phase. Okay, so what is saying that is evidence to show that ions, okay, in solid state exist as this state, because in this state they cannot conduct electricity. Only when we melt them or when we dissolve them in water, then they can conduct electricity. Okay, so that's why ions in solid state have to exist in a lattice structure. Okay, this is like a proof that this lattice structure exists and is not just in theory. Okay, and this is important because it's one of the part of the learning objective. Okay, that'll be all for the introduction to electrolysis. Okay, we'll talk about individual electrolysis like a dilute solution, concentrated solution, and simple cells in further videos. Okay, so stay tuned.